All right, let's keep going. Let's see. I'd like to go over the assignment for this week. Let's see. It should be available now. So there it is. Let's open it up. I don't know if you could see it. Oh, it's being cut off here, huh? Let me close this. And let me open. I'll provide a link to this as well, so that you can see it better on Google Docs. Yes.
The submission is tonight.
Oh, for this one?
Yeah.
Oh, okay. I'll change that. I have a lot of faith in you. Here we go. So this is the second part of the project that we're building throughout the semester. The first one was creating a data model using analyzing the data, what the structure was, and coming up with a UML class diagram. And I expect that every one of you will have a different class diagram. Obviously you'll probably have things that are somewhat similar, but some of you might have had different interpretations, and certainly there will be a lot of review that would go on in the real environments where there's a lot of discussion back and forth on how to best capture the data, right? So as long as you can defend your decision one way or another, typically this would go through several iterations, right, before we all agree on what a particular class diagram is. So here's one that captures just some of the aspects of what we talked about last week. That captures different users, different types of users that that are all people, right? They're all persons, and they capture some of the things that are in common with all folks. They all have first names. Everybody has last names, username, passwords, whatnot. But different types of user might have specific pieces of information, such as a developer might need a developer key and might have some relationship with the application. Yes.
Looking at the creation purposes, the developer has one or more privileges.
Yes.
So is it like you're saying like there cannot be any developer without a page privilege?
Without a what?
Page privilege entry.
Page privilege. I believe over here is a page privilege down below.
Oh, base privilege. Like you can't have no privileges.
Oh, no privileges.
Yeah.
I believe what did we say in the assignment? I forget. Did it say 0 or more?
There's no.
It didn't say. Yeah. Well, here I am assuming that yes, there's at least one privilege on one of these. Yes. Yep. Right. So there can't be a record, right, unless that person has a particular privilege, right? I mean, either the owner of the application or of the website and whatnot. Yep. Let me see if I can make this a little bigger. And also notice that we have a specialization here where the developers and the users, they both inherit from this base class person, and they all have multiple phones, multiple addresses. I didn't capture email, just had here, there's just one email, but we can certainly expand that. And notice that here, right, it's a composition that if we do remove the record for the person, we also remove the records for the phones and addresses. We don't keep them around. And down below here, we see that developer has an aggregate, a relationship with websites. That meaning that if we do remove the developer, we not necessarily remove the website. We keep it around. We also have multiple relationships between the developer and the website. Or developer and a page. We can keep track of individual privileges and individual roles for the website and also for the page. Those roles and privileges are taken from enumerator data types, right? That keep track of the various roles that they can have. They can have multiple roles for website and page, and we can keep track of multiple of those over here. Whereas the privileges we have listed in a different enumerator data type. We have here that a developer can build or participate in any number of websites. Here you could argue that this could be a mapping, right? And I see that several of you that have already submitted have a mapping table here, and certainly that would be one way to implement it, right? As opposed to having just one-to-many, you can have a many-to-many, right, of users in one of the websites. Here you have also websites having any number of pages. If you remove the websites, the pages are gone, right? And also we have pages containing many widgets. If we remove the page, the widget is gone. Okay. Yes.
If a developer is removed, what happens to the website?
It still stays along.
So shouldn't that be 0 and 1?
No, well, this says that if there is a website, there is a. Oh, okay, right. Yes, those would be 0. Yes, okay, I'll change it to 0. Thank you. Here we have a widget. It's a base class, right, that keeps track of all the common attributes of all widgets. All widgets have names, widths, heights, classes, styles, text, and the order. And then you have special cases where you have YouTube, images, headings, and HTML, which all inherit from this base class that add their own specific attributes, such as URLs, whether they're shareable, whether they're expandable into full screen. You have images with sources, HTML with the actual HTML string containing there, and the size of that particular heading. Okay. Then down below, it asks you, okay, well, given this class diagram, which presumably you came up with it in the first assignment, right? Now, after having gone through several iterations of improvement and approvals, actually implemented in a concrete schema, right? In this particular case, we're going to implement it in an SQL schema, meaning using tables and fields and foreign keys and primary keys and whatnot, and implement it in various tables that implement persons, developers, and users. So the first part here for 5 points, give me the create statements, right, in SQL that creates these three tables over here: persons, users, and developers. Right. Specifically, what the challenge here is that there's a base class, right, and you have 2 classes that inherit from this base class, right? There's multiple ways of implementing that in SQL. I'm asking you to implement it in a particular way, right? Where you're going to have separate tables for each one. You're going to have a base. You're going to have a class. You're going to have a table that captures all the fields that are common to all people, right? So you have a separate table for persons, a separate table for users, and a separate table for developers. And the way it's going to happen here is that the person is going to hold the primary key, okay, and the users and developer tables are going to have foreign keys that are going to be also primary keys that are going to refer to the primary key in the persons, right? So that if you want to retrieve a developer record, you are always going to have to join these two, right, to retrieve the full record for that particular developer. Or if you want the information for a user, you're going to have to join both the person and the user table to retrieve the full record for that user. Okay, and so they're basically the one record in the person and one record in the user is just a normalization, right, where you have the specific information about a user in one table and the common information in the other table, right? And they're both part of the same thing, or part of the same entity. If you remove one, you have to remove the other, right? And we'll go over that a little later, how to do that. And it says name. It says implement generalization using separate tables. Uh-oh, what is this? What? I'm trying to select. Oh, I know why. It's a. I was zooming in. I was zoomed in. Implemented as separate tables per class, right? That's one of the ways of implementing generalization and specialization using SQL. We'll go over that in a minute. Another way to implement it is I'm going to ask you to do something different for the widgets. See that? For the widgets, I'm going to ask you not to use multiple tables. Instead, I'm going to ask you to use what's called a denormalized implementation, where you flatten the hierarchy, right? Instead of having 5 different tables, right? Instead, what you create is one fat widget table that's going to collect all the fields from all the various types of widgets, okay? Right? Of which one record is going to capture the information for a YouTube video. Another record will capture the values for an image. In those cases, if it's an image, then all the fields for the URL, the shareable, and the expandable are going to be nulls, because I'm not a YouTube widget, right? I'm an image widget. Yes. So a lot of the fields in the widget table are going to be null, right? And they're not going to be null depending on the type of the widget. Make sense? Right? It's a denormalized implementation. Okay. And oftentimes you choose one or another. Okay. If it's a very hierarchical class inheritance tree, right? Joining so many tables in the hierarchy is very expensive, right? So oftentimes for performance reasons, right, we flatten the hierarchy into a single denormalized implementation, right? So for performance reasons, you might choose one or another implementation. Here I'm asking you to do both, right? For this generalization, I'm going to ask you to use the multiple table implementation, right? For this one, I'm going to ask you the denormalized implementation, right? Later on, when we'll see JPA and object relational mapping, right? When you ask JDBC and JPA to map it to a schema, you can ask the schema to either use the multiple class strategy or use a denormalized strategy, right? Depending on what schema you want to choose, which is pretty cool. Over here, you're going to do it by hand. Later on, when we look at JPA and ORMs, we'll be using tools. You just push a button and it generates all the schema for you depending on the strategy that you choose. Make sense? Right. But first, let's practice doing it by hand. All right. So the first 5 points ask you to create these 3 tables over here. The next 5 points ask you to create these tables over here: the website, page, and widget. And these over here, these. And for widgets, it'll be just one class, one table. Right, one table which is going to be representing all these 5 classes. Yes? Right, so basically just 3 tables over here. And then create the address and phones tables over here. Okay, making sure that you use cascade delete. Right, making sure that if you delete the person, it also deletes the phones and the addresses. Be careful there. And finally, implement the relationships here for the website privileges and the roles, right? And I don't believe I'm asked. I don't know if I'm asking you. I give you points for the enumerated data types. You'll also need to create the enumerated data types, but I don't believe I give you points for that. Yes.
How do you handle deletion in terms of specialization in
So here as well, right? If you remove the person instance, you also have to remove the user instance. Right, so yes, you would do a cascade delete and also a cascade update, right? So that if the ID changes or the primary key changes, the foreign key also needs to change. Or if you remove the person, right, it makes no sense to keep around the user or keep around the developer. So it would cascade as well. Yep. I don't believe do I ask you? Oh, I also ask you to name the schema homework 2. and also the last name and first name, your last name, your first name, to name the schema. Because what the TAs are going to do, right, they're going to take your schema, right, they're going to load it into their local databases and run your SQL, right? So they're going to have, several dozen folks, right, in the same database. So that they don't collide, please use a unique schema name, right, so that it does not collide with other students' names, so that it make it easier on the TAs to grade this. All right, you're going to provide a single file, a single SQL file that implements all this, right? That drops the schemas, creates the schemas, and then does several SQL statements. Everybody okay? Okay, so 20 points for creating the schema. The next 20 points is creating data, right? Just doing all sorts of inserts to populate the data with the following information. Okay, so the first one is 4 points to populate the following users and developers. All right, so there's five users and developers. Here I tell you what type these are, whether the developers or users. That means that you're going to have to insert into the person table and the user table, yes? Or insert into the person table and the developer table. Yes? So these three, the first three, you'll need to insert into both the developer table and the person table. Yes? Meaning these fields here will go into the person table, whereas the key, was going to go into the developer table. Correct? Right? And the primary key of the person table needs to match the primary key and foreign key of the developer table. Yes? We'll go over that in a minute. Whereas these two will go into the person table and the user table. Make sense? All right. The next here is asking you to create several websites. Okay, so given the owners here, so you're going to create several. Several websites. These are the names, descriptions, and the various roles that each one of these users, the previous users were used that were declared earlier, right? And some of the visits. So those are all inserted into the website table. Then 4 points for that. So they'll what? It's 1, 2, 3, 4, 5, 6 inserts. Then you're going to create several pages. Okay, so given a website, you're going to insert pages into the websites. So it'll be about five pages, and you're going to set. So you create 5 inserts for the pages, but then you'll also need to set editors, reviews, and writers, right? So you're going to insert into these other tables, right? The website privileges, website roles, or page privileges, or page roles. Yes? Okay. What else? Let's see. So those are pages, and finally, widgets. You're gonna insert into the widget table. There's only one widget table, right? So you don't need to insert in into a whole bunch of tables, right? Because there's only one widget table, but some of the values are going to be null, right? So for instance, here since this is a heading, right? All the fields for YouTube, for images, for HTML, those are all going to be null, right? We're only going to be having the value for the size. Oh, I don't have size. I don't have size for this. All right, you can put a random size into that widget. Or actually, that'd be a good idea to have a default. We'll have a default. Yeah, let me put that in here. And I'm going to put here in the widgets, widget, default heading size should be 2. Okay. So that's that. Okay. So now it's compatible with this, right? If I don't tell you the size of the widget, then of the heading widget, then it should be 2, right? Which I don't. Let's see what else. Also notice that these have orders. See that widgets are displayed in a particular order, right? Presumably, we should be able to grab them, right, and move them around, right, and put them in a different order, right? So it would have to be updated over here, right? The challenge, as we'll see in a minute, is that if you reorder a widget, the order of all the other widgets needs to change, right? So if you change the 5th widget and you put it in the 0th position, right, all the ones in between need to change, right? Right, 0 has to become 1, 1 has to become 2, 2 has to become 3, and so on and so forth, right? So we'll need to deal with that. And here are the addresses and phones for Alice, Bob, and Charlie, where the bold are the primary phones and primary addresses. Everybody okay?
Can you explain the order again?
Yeah. So the order keeps track on which widget should display first in a list of widgets on a page, right?
Are you saying the orders that you gave, the ones that do fits your relative ordering?
Yes.
So when
Yep.
you insert 0, then we need to increment everything else?
No, it says that
So
is
it's literally those numbers. It's
literally those numbers.
Okay.
But later, right, in the update portion of the assignment,
Okay.
I ask you to move a particular widget from one position to another position, right? And that means that all the widgets between those two positions need to update, right? So if you move, I'm sorry.
What if they have the same position? Like here you have 3 zeros.
Yes, but they are in different pages. In different pages. So no, you should not have the same position, right? If you're in the same page. If you're in different pages, then yes, you can have all zeros. So for instance, these 3 widgets are all in the contact page, right? And they have positions 1, 2, 3. And I believe later on in the assignment, I ask you, move, widget 3 to the first position. Somebody's dragging it, right? So if this becomes 1, then 1 has to become 2, 2 has to become 3. Make sense? All right. So here's a couple of queries. Most of them are simple enough. Retrieve all the developers. So that's a one-liner. And then it says, well, retrieve the developer whose ID is 34. So again, that's another one-liner. So this one says, okay, well, retrieve all the developers who have a role in Twitter other than the owner. Right, so that means you're going to have to join a couple of tables here, right? The developer along with the person along with the role that goes along with the website, right? So you need to join those 3 tables, and I believe I give you the right answers, Charlie and Alice. Those 2 should be your answer. So this one says retrieve all the developers who are page reviewers, so have the role of reviewers on pages that have less than 300,000 visits. So that's Charlie. Again, you'll need to join several pages and ask whether the views are less than 300,000. So retrieve all the writers, the writer developers who added heading widgets in CNET's homepage, which is also Charlie. Right, so these should be, most of these are trivial. So same thing for website. I ask you to retrieve all the websites with the least number of visits. Retrieve the name of the website whose ID is 678, so that's trivial, that's one-liner. Retrieve all websites with videos reviewed by Bob. Retrieve all websites where Alice is an owner. So these are several joins. There are quite a few joins here. And then updates. So here's a developer, update the developer. Charlie, update Charlie's primary phone number to 33445555. So that's an update with a where clause. Here's update a widget whose relative order is on the page, its new order is 3. So whatever its order was, I forget what it is. I think its order is 1. It asks you to move it down to order number 3. Note that other widgets order needs to be updated as well. Okay. Append. So this is appending CNET to the beginning of all the page titles. Okay, and then swap Charlie's and Bob's role in the CNET's homepage. And finally, implement deletes. Delete Alice's primary address. Remove the last widget in the contact page. So the last widget is the one with the highest value in the order field. So the last, right, is the one that has, right? Remove the last updated page in Wikipedia. And remove the CNET website, as well as all related roles and privileges relating developers to websites and pages. Once you remove a user, everything has to follow, right? Everything gets to be blown away. Yes?
So are you expecting us to deliver like
One
tables,
single file.
or just a list of the commands?
The inserts, updates,
You want the like words we use, not the table.
the actual statements that you use on a query.
Not the results of that.
Not the results.
Okay, just making sure.
Right, yeah. Okay. Also, the assignment has a rubric associated, which I think you should be able to see it. And for each one of the criteria that is listed in the assignment, the TAs are just going to go, giving you scores and hopefully feedback as well for each one of them that if you lost any points. Okay, and when is it due?
It is due 2 weeks from today.
So what were you saying that was due when?
Today's assignment, the assignment 1 is due today.
At midnight.
Yeah, assignment 1 is due today, but you were saying assignment 2 was due when?
I said you were showing the class diagrams. I said,
Oh, okay. Yeah, no, it's fine. Okay, awesome. Any questions?
So for the tables that had names like Alice, Bob, Charlie.
Yes.
Can we just when we insert, do we just hard code the
Yep.
values even though they appear multiple times in multiple tables?
Yes. Yep. Yep. All right, let's keep going.